Hello, it's Jacob again, and in this video, we'll be talking about gains from trade. So, how can we measure the gains from trade? Trade occurs because it makes both parties better off. This seems like it seems obvious, frankly, but that's a point that's often forgotten. People have a tendency to view trade as a sort of competition in which your goal is to screw over your trade partner. People whine about their employers. Employers whine about their suppliers. Everyone whines about stores. Everyone always wants a better deal. Yet, despite all the whining and moralizing, people still voluntarily show up to trade because trade makes them better off. And when trade is not voluntary, it's not really trade at all. You might sometimes see things inaccurately described that way, but understand that when we talk about trade in this course, we mean exchanges of goods and services that are made voluntarily. Now, you might still say that someone is coerced by circumstances, right? Somebody needs a product, but there is no physical violence being used to compel them to buy a product or to provide their labor. Those would be theft and slavery, respectively. Now, in order for trade to make sense, the consumer must find that the marginal benefits of the good exceed the marginal cost of providing the good. But those marginal benefits and those marginal costs, they don't have to be the same from person to person. Indeed, if they were the same, there would be no rationale for trade. If everyone could produce goods equally efficiently, then there would be no reason for anyone to exchange, as opposed to just being completely self-sufficient. Yet you'll find that even in situations where the costs are the same, people might also have different benefits as well. They have different needs, and they also have different subjective valuations on goods and services. One of the remarkable things about trade is that it actually creates value in and of itself because it transfers goods from low value to high value uses. By taking resources from someone who has a low benefit of owning them and giving them to someone who has a high benefit, a society is made wealthier even if the total amount of resources stay the same. But what we want to know is, how can we fit this into a supply and demand framework? Now, remember that the marginal demand, remember that the demand curve shows the marginal benefits and the maximum willingness to pay at each unit. And the marginal benefit also falls as the quantity increases. That would be our law of demand. And for the consumer, the marginal cost of a purchase is going to be the price. It's going to be that which they have to hand over to the producer. Now, there may be other costs for the consumer associated with consuming a good. We already talked a little bit about that with our Jevons paradox. There might be other products that they also have to buy to go with it, like batteries, electricity, fuel. There might be time costs. You know, how much time does it take you to buy it, and how much time does it take you to use the good? But these things can be regarded as reducing the marginal benefit. When we do our supply and demand graphs, the whole point is that we're showing how the consumer and the producer respond to the same price, right? So the price must be defined in such a way that it's only that which the two have in common. that which the consumer gives to the producer, and that they equally value, so that we can meaningfully calculate. Everything else would just be considered a reduction in the demand if you have to buy other goods to go with it, if it takes you more time to use the good. And so the net value of a given unit should be the difference between the marginal willingness to pay and the price for the consumer, I mean. So consider this scenario. We're looking at the market for Thneeds, and the consumer would be willing to pay $12 for the first Thneed, $10 for their second Thneed, $8 for the third, and $6 for the fourth. But because it's a competitive market, you only have to pay $6 for each. $6 is the price, regardless of how many you're buying. There are certain business models that don't strictly adhere to that. It's a little bit beyond the scope of what we're going to talk about, but just so you know, I am aware that there are buy one get one free deals. There's bulk deals. There's businesses that charge you different fees depending on the like the status of your membership and so on. In a normal store, though, this is pretty typical. And so, how much better off are you made by your Thneed purchases? Well, for that first Thneed, you're made $12 better off. How do we know? 12 is the most you're willing to pay for it. But you only had to pay $6. And so you effectively saved $6. Then for that second Thneed, it was worth $10 to you. That's the most you would have paid, but you only had to pay $6. And so that's $4. And then that third Thneed, you paid $8 for. Or sorry, you would have been willing to pay $8 for, but you only had to pay $6. That's $2. And then the last one you broke even on. And so your total savings are $12. Now, we call this measurement consumer surplus. And I do feel the need to give you the econ jargon term, if for no other reason than that's what the textbook calls it. But you can think of it as being the savings. The savings that the consumer has because they're able to buy things for cheaper than they would have been willing to pay. And the surplus can be interpreted from the graph as being the sum of the rectangles drawn between the quantities, the demand curve, and the equilibrium price line. This line right here. Now, in real life, it's too complicated to count up individual rectangles when dealing with goods that are bought in massive amounts, potentially millions, even billions of units. And so instead, we'll use a heuristic and approximate the savings by taking the area between the demand curve and the price line. And this is especially appropriate for massive amounts, like talking about market demand instead of individual demand. And it's appropriate for goods that are infinitely divisible, like deli meat, where you can order a weight. If you've had calculus, this idea is going to be familiar because it's actually the reverse of the logic of using an approximation. In calculus, you were first taught how to approximate the area under a curve using rectangles, but then you were taught the right way to do it. Here, the rectangles are the right way to do it, but you would use calculus because that would be easier. I don't make you do geometry in this class. In the principles classes, they do 2110 and 2120. They require you to calculate areas of figures. By the way, I didn't specify it, but I hope y'all understand these curves, they're not straight lines in real life. A real supply and demand curve, you know, it's going to look something more like that. But it doesn't matter, and it makes it a heck of a lot easier to draw if I do it, you know, with straight lines. Well, your big takeaway. The vertical gap between the demand curve and the price line is the savings on any one unit. And so if we add up all of those gaps going horizontally, we've added the savings on all the units purchased. And this triangle is going to be our consumer surplus, the amount that the consumer is made better off by trade. The bigger the triangle is, the better it is. Now, what about the producer? Well, whereas the consumer views the price as a cost, the producer views the price as a benefit because that's what they're getting paid. And we know that their supply curve is a curve of marginal costs or opportunity costs. And so the producer's economic profit on a unit is the price minus the opportunity cost. This is something that I'm going to annotate it here. When we're talking supply and demand, we're talking about economic profit, not accounting profit. So the difference is that accounting profit would be the actual net cash you have after doing business, the revenues minus the costs. Economic profit would consider all of the opportunity costs, not just the financial ones. So if using resources to produce a certain good meant that you did not sell a different product, the lost profits from your alternatives count in your economic profit. I won't test you on the distinction, but I wanted to bring it up. Now, we can approach this the same way we did consumer surplus. So the producer, they're selling 4 units at equilibrium. They're getting $6 per unit, $6 per need. And what are they paying to make them? $1 for the first need, $2 for the second one, $4 for the third one, and $6 for the last one. And when you work it out, that comes out to $11 total. In the graph, it's symmetrical because, again, the graph is just a graph. That's not a real problem. But there's no rule that says that the consumer and producer surplus have to equal each other. It would actually be a small miracle if they did. And when we combine these two things, we get what's called total surplus. Consumer surplus plus producer surplus. As we go along through this course, through the microeconomics half of it, we're going to be adding in more things, external benefits, external costs, government revenues, deadweight loss. For now, though, consumer surplus and producer surplus is considered our total surplus, the total amount that society is better off for this trade being able to take place. Now, note that the consumer is saving and the producer is profiting at the same time. Now, the consumer is spending money, yes, but they're saving in the sense that they are receiving benefits that they would not otherwise have been able to get. They would have been willing to pay more, yet they didn't have to pay more, and so they are saving. And one side might benefit more than the other, but both of them are benefiting. So what happens here is trade transfers goods and services, or the resources that are used to make them, from low-value uses to high-value uses. And then the consumer and producer share the difference. And you can see that here. How much was there to gain? Well, any price between $12 and $1 would have been acceptable to both of them. Any price between 10 and 2 would have been acceptable to both of them. Between 8 and 4 would have been acceptable to both of them. On each marginal unit, they could have struck a deal somewhere between the two curves. But thanks to competition, they have to share it. One cannot just compel the other one to provide. Certainly not to their detriment, as you would expect with slavery and theft. And it's not uncommon for each side in a trade to think they're swindling the other. There's one in The Rational Optimist, your first book that you have to read, that I like. As Matt Ridley says, it is common to find that two traders both think their counterparts are idiotically overpaying. That is the beauty of Ricardo's magic trick. The English have no sense, said a Montagnais trapper to a French missionary in 17th century Canada. They give us 20 knives for this one beaver skin. The contempt was mutual. When HMS Dolphin's sailors found that a 20-penny iron nail could buy a sexual encounter on Tahiti in 1767, neither sailors nor Tahitian men could believe their luck. Whether the Tahitian women were as happy as their menfolk about this bargain goes unrecorded. 12 days later, rampant inflation had set in, and sex now cost a 9-inch marlin spike. This is a common theme you find in stories of trade. Often you'll hear about things like, so Ridley refers to the Montagnais up in Canada. You'll often hear these stories about trade between Indians and colonists in early America, where they'll say how, you know, they would trade like 50 deer skins to get one musket. And then the European would go on to sell those deer skins for, you know, an unfathomably higher amount of money. Mostly we get the European perspective on it because they were the ones that left the records. But for the Indians, it was a great deal. Imagine you have this thunder stick, this fearsome weapon that, you know, belches fire, that kills without even being seen, and you have no way to produce it. You don't know how to make them, but you have an abundance of animals. You have an abundance of deer, you know, running around the woods. That's a good deal. That's a good deal to you to get something very rare, very unique, very special that you have no means of making, just by giving up something that is cheap to you, something that has very low value to you. Well, the Europeans, they were thinking the same way. They didn't have easy access to massive forests full to the brim with fur-bearing animals, but they had easy access to manufacturing, and they had access to markets with which to sell these products. This, I think, is what Ridley means about this tendency to view trade in an exploitative manner. If you look at the value of the finished product, where it finally winds up, and you compare it to the value of the raw resources at the beginning of the chain, it tends to look like people earlier in the chain are getting screwed over because they don't get to reap the full rewards. But the thing is, everyone in the chain depends on everyone else. And they're all splitting the profits between them. Some parties are going to wind up doing better from it than others, but they wouldn't show up to the trading post unless they were benefiting from it. And that same product to different eyes can have very different values, very different valuations. Now, elasticity is also going to have a big impact on who benefits more. And what you'll find is that the more elastic party actually benefits less. And the reason is that their marginal benefits or marginal costs, depending on which role they're in, they change less quickly, so they have less savings or profits. See, if they can substitute to a different good or change their line of work easily, they have less to gain from a good deal in a specific market. And you see down here, there's graphs demonstrating this. With perfectly inelastic supply, almost all of the benefits are going to that producer. But with perfectly elastic supply, they get none of the benefits. That could be a case too. Because we're talking about economic profits and not accounting profits, in this scenario, the perfectly elastic supply scenario, that could still be a profitable business in the sense that it's producing, net wealth for the owner. It's just that it's not producing more wealth than if they were in any other line of work. The party that is more desperate is the one that has more to gain because they're more desperate. So in conclusion, I know this one was a short one. In conclusion, we can measure the gains from trade, and we call it consumer and producer surplus. Consumer surplus is the savings gotten from a good deal, while producer surplus is the economic profit made from a good deal. And graphically, these are triangles made from the respective curves and their price line. But now we have all the basic tools we need. And so we can begin our analysis of the effects of policy and market failures. And first, we're going to start with a study of price controls, and we'll see how non-equilibrium prices reduce the total surplus.